Alright, so I think this is recording. Let's take a look at the next problem in these inverse functions. And sorry about that, they are misnumbered. They are not numbered correctly on your worksheet. Sorry about that. Alright, so let's take a look at number 5. Well, this time when we were typing it up, rather than using f, we just called this function h. Alright, so what do I know about this function? Well, I'm familiar with it because in Algebra 1, you studied lines quite a bit. The graph of this is just a line. If you thought of it, and let's go ahead and write it in rather than using function notation, if we just use x and y notation, we can see that that's in slope-intercept form. The slope-intercept form for the equation of the line makes it easy to identify the slope and the y-intercept by inspection. So I know that the slope of this line is the coefficient in front of x, and we generally refer to that as m, and this is 3. You can write 3 as 3 over 1 and think of it as rise over run. And the b is the y-intercept. That's where the graph intersects the y-axis, and we can see here that that's 4. So with this guy being 4, and it's a steeper graph, so I know that the graph looks something like this, and so it clearly is a function because it passes the vertical line test. Well, we know that so I always think of it as first that I have a relation between x and y. I have a collection of ordered pairs, x and y. And then this relation, I think of it like a promotion. The title of it changes, and it gets promoted to the title of function. So this relation gets promoted to the title of function because every element in the domain corresponds to a unique element in the range. Well, now that I have this function that passed the vertical line test, there's another test called the horizontal line test, and if it passes the horizontal line test, then it gets I think of it as getting another promotion, and the new title is a one-to-one function. Now, the reason I'm interested in one-to-one functions is one-to-one functions have inverses, and that inverse relation will also be a function. So it's asking me in this problem to come up with the equation for the inverse for this function, and then to identify that inverse relation as a function or not. Well, because this h is a one-to-one function, I know that its inverse is also going to be a function, and that it will be a one-to-one function. Alright, so the technique for finding the equation, well, the idea of an inverse is you're switching the domain and range. So when we're finding the equation, we switch the variables x and y. And now we solve this equation for y, which is pretty simple. We subtract 4 from each side, and then we divide each side by 3. So we have x minus 4 divided by 3. Now, that's fine to leave it like that, but it's possible that some people may not recognize quite as quickly that this is also a line. So let's recognize that this single fraction can be broken apart into two fractions, that each term in the numerator gets divided by 3, and then we typically will, to divide by 3 is the same thing as to multiply by the reciprocal of 3. The reciprocal of 3 is 1/3, and now you can see that, recognize really quickly that this is also a line, that this is in slope-intercept form, that the slope is 1/3, the y-intercept is negative 4/3, and from our previous discussion and thought of what 3x plus 4 looks like, I know that I can use this function notation, and that these two are inverses of each other, and they are both functions. So they are both one-to-one functions. So there is my answer for number 5. All right, hope that helps.